Okay, I wanted to make sure that I go over some of the CBA questions that we didn't talk about in class. Okay, so I am going to go over some of the stuff that is in the waves and electrons section. Okay, so I'm going to start with number 42. Calculate the frequency of red light with wavelength of 6.50 times 10 to the negative 7 meters. Okay, so number 42 all the way through, let's see, 42 all the way through 46 are pretty much the same type of questions, and these have to do with wavelength, frequency, and energy of waves and light. Okay, so there are three variables that you need to be aware of. The first one is frequency, which is F, okay, right here. And the second one is wavelength, which is lambda. We kind of talked about this in class, at least the symbol for wavelength, okay, and that is the Greek letter. And there is another variable in here that's called energy, and that is a capital E, but number 42 doesn't have energy involved. So we will get into one of the questions that actually has energy involved in it, okay, but number 42 doesn't. Alright, so we are going to solve these using the 5-step method. Okay, so if you remember the 5-step method, the first step was the given. And in this case, we are given the wavelength. Wavelength is 6.50 times 10 to the negative 7 meters. Okay? Alright, and then the second step is what is the answer that we are looking for. And in this case, we are looking for the frequency, F, and frequency is measured in hertz. Okay? Okay, now for the third step, what you need to do is get the formula chart that I gave you in class. It is the green sheet of paper that doesn't have the periodic table on the other side of it. Okay, so it looks like this. Alright. And we are going to be concentrating on the atomic structure section. So it is the first section that is on the front side, okay? And the three formulas that we are going to be dealing with are these three, okay? The speed of light equals frequency times wavelength, energy equals Planck's constant times the frequency, and energy equals Planck's constant times the speed of light divided by the wavelength. And we have the variables over here, okay? The speed of light is c, and Planck's constant is h. And like we said before, F is frequency, lambda is wavelength, and E is energy, okay? Alright, in this case, our given for number 42 was wavelength, and the answer that we're looking for was frequency. So therefore, we have to use the formula that has both of those in them, okay? So we have to use a formula that has both the frequency and the wavelength, and it turns out to be this first one, C equals F times lambda. So I will be using C equals F lambda as the formula, okay? Now, we can easily put this into a formula triangle so that we don't have to do algebra, okay? And in this case, C will be on the top, and F and lambda will be on the bottom. We are looking for F, so I'm going to cover up F with my finger, alright? And it looks like I'm actually going to use the F equals C over lambda formula, okay? Alright, now on the other side of the formula chart, under constant and conversions, we got H equals Planck's constant, and it tells you what it is, 6.63 times 10 to the negative 34 joules times second, okay? And C equals speed of light equals 3.00 times 10 to the 8 meters per second. So we have C in this problem. I'm going to use that number. F equals 3.00 times 10 to the 8th meters per second. Alright, that is over the wavelength 6.50 times 10 to the negative 7 meters. Alright, and then all we have to do is punch this into the calculator. Don't forget that when you are putting in a scientific notation, you do not use times 10, you use E, okay? So I'm going to go ahead and punch this into my calculator. Okay, so here is my answer. 4.61538465 times 10 to the 14th power. Alright, in this case we have 3 sig figs in the given, so I'm going to have to round to 3 sig figs. So it'll be 4.62 times 10 to the 14th power, and frequency is measured in hertz. Okay. Number 43, what is the energy of a radiation with wavelength 1.00 times 10 to the negative 6 meters? So in this case, the two variables that we have, energy is E, wavelength is lambda. So our given is the wavelength, where lambda equals 1.00 times 10 to the negative 6 meters. Okay, and the answer that I am looking for is the energy, and energy is measured in joules, or J. Okay, the third step, I'm going to go to my formula chart, and it looks like I have lambda and energy. Okay, I have lambda, wavelength, and energy, and the one formula that has both of them is this third one. Energy equals Planck's constant, h, times the speed of light, c, divided by the wavelength, lambda. Okay? So I'm going to write that down for my step 3. E equals hc over lambda. The formula triangle is going to look like this. hc on the top. H times c will always be the same number, so we can put them both on the top, okay? And E and lambda are on the bottom. Okay, now in this case we are looking for E. If I cover up E with my finger, it's going to be hc over lambda. So it's just the exact same formula that was on the formula chart. So I don't have to rearrange it. All I need to do is plug in, okay? So E equals H. If you look up H on the formula chart, you will see that it is 6.63 times 10 to the negative 34 joules times seconds. Okay? And we are going to multiply this number by C, which is 3.00 times 10 to the 8th power meters per second. And we're going to divide this whole thing by the lambda, 1.00 times 10 to the negative 6 meters. This was just our given. Okay? Alright, and now all I have to do is punch this into my calculator. And it looks like we have to have 3 sig figs because our answer, or our given, was in 3 sig figs. And again, make sure you remember that the scientific notation must be entered in as a double E or EXP, okay? Alright, and my answer came out to be 1.989 times 10 to the negative 19. Rounding that to 3 sig figs is going to be 1.99 times 10 to the negative 19 power joules. Okay, number 44. What is the energy of violet light with a frequency of 7.50 times 10 to the 14th power hertz? We have energy and we have frequency. Okay, so in this problem, the given was the frequency, so F equals 7.50 times 10 to the 14th power hertz. Second step, what am I looking for? I'm looking for the energy. E equals something joules. Alright, my third step, I'm going to look up the formulas on my formula chart again. Looks like I have E and F, so I need to find the formula that has both E and F in it, and it looks like it's the second one. Okay, E equals H times F. So I'm going to write that down. E equals H times F, and the formula triangle is going to look like this. E on the top, H and F on the bottom. Okay, and I am looking for E, so if I cover up E in the formula triangle, it's just H times F. So it really is the same thing as the original formula, so I don't have to rearrange anything. And I'm just going to plug it in. Okay, E equals H, if you look it up, or if you remember from the last problem, it's 6.63 times 10 to the negative 34 power joules times seconds. And I'm going to put this in a parentheses to make it easier for me to distinguish, okay? And the F is our given, 7.50 times 10 to the 14th power hertz. Okay, and that's it. All I need to do now is punch it into the calculator, and I will need 3 sig figs. And here is the answer from the calculator, 4.9725 times 10 to the negative 19. I need to round this to 3 sig figs, so it's going to be rounded to 4.97 times 10 to the negative 19 power, and the answer is in joules. Alright, so that's number 44. I'm going to go on to the next page. Number 45. What is the wavelength in meters of a light that has a frequency of 6.6 times 10 to the 14th power hertz? Alright, we have wavelength, which is lambda, and we have frequency, which is f. Okay? The given in this case was the frequency, and the frequency is 6.6 times 10 to the 14th power hertz. Second step, the answer that I'm looking for is the wavelength. Lambda equals something, and wavelength is, we're going to look for it in meters. Okay? Alright, the third step, look it up on the formula chart. We have lambda and f. And so if you look it up on the formula chart, it looks like we're going to use the first formula, C equals F times lambda. I've already gone over the formula triangle, but I'm going to draw it again. C is on the top, F and lambda on the bottom two sections. Okay? So we are looking for wavelength in this problem, so I'm going to cover up wavelength, lambda, in the triangle, and looks like it's going to be lambda equals C over F. There we go. Okay, so now for my fourth step, all I'm going to do is plug in. Okay, so it's going to be lambda equals C is 3.00 times 10 to the 8th power meters per second. That's the speed of light, and remember that you can just look that up on the back of the formula chart. Okay, and that's going to be over our given, the frequency, 6.6 times 10 to the 14th power hertz. Okay. So my given has 2 sig figs, which means my answer must have 2 sig figs. And let me punch this into my calculator. And here's my answer. 0.000000455. Okay, so I need 2 sig figs. The zeros don't count. I am going to have to round this to 0.0000046. So that is the answer. 0.000000046, and the answer's unit is meters. Okay, and finally for number 46, the last one of this type of question. An FM radio station broadcasts at a frequency of 107.9 megahertz. The big M is mega. What is the wavelength of the radio signal? And gave you a hint, convert megahertz into hertz first. And it tells you that 1 megahertz is equal to 1 times 10 to the 6th power hertz. So I am going to go ahead and take that hint and say my given is the frequency, and that's equal to 107.9 megahertz. Now I'm going to go ahead and change that to hertz. So I'm going to do a dimensional analysis grid because I'm doing conversion. Okay? Now, since megahertz is on the top, I'm going to put megahertz on the bottom. And that's 1 megahertz. And on the top is 1 times 10 to the 6th power hertz. Alright, megahertz will cancel out. And all I need to do is take 107.9. And my dog is running around. 107.9 times 1 times 10 to the 6th power. And this will actually give me 107.90000 hertz. Okay, so that is my given. The answer that I'm looking for is the wavelength. It's right here. Okay, it says what is the wavelength? That's lambda. So lambda is going to be measured in meters. Alright, and then all I have to do is look up the formula on the formula chart. I have F and lambda. So it looks like I'm going to have to use this first formula, C equals F times lambda. Right, I'm going to use my formula triangle. C is on the top, F and lambda on the bottom. Okay, I'm looking for lambda, so I'm going to cover up lambda, and it looks like it is C over F. So lambda equals C over F. This is just a rearranged formula. Okay. Alright, the fourth step is plugging it in. So I'm going to take C, which is 3.00 times 10 to the 8th meters per second, divide by the frequency, which we have changed into hertz. 107.90000 hertz. Okay. And now all you have to do is plug this in to the calculator. And looks like my answer has 4 sig figs, so my answer will have to, or my given has 4 sig figs, so my answer will have to be rounded to 4 sig figs. So my answer is going to be rounded to 2.780 meters. Okay, and that's the wavelength, frequency, and calculation problems.